and play it out. Since when we call the night, be sure to make it right till the dead of night. You gonna like it loud. Since when we call the night, this time we'll make it right. Now it's time to start. Come on, you know it's right. This time we'll make it loud. You better try it hard. Show me what you got. The show's about to start.
What's up, hackers? Welcome to TTI Live. My name is Taggart. I think I remember how to do this. Wow. Been a minute? And, I've been a little busy. But we have lots of cool stuff going on, that I want to talk about. But today, since we've had some changes at TTI, I am relaxing my grip a little bit on the structure of streams when they get to happen, because they can be a little bit more fun, right? They can be a little bit more freeform, a little bit more audience driven. I'll save my lesson planning obsessions for live classes with the members and also any recorded YouTube stuff that we do. So today I had some time to stream and I thought it would be cool to see all of you. But there's a lot of options we have, so I thought I'd leave it up to you what we actually get up to today. I will give you a limited set of options just because I'm not capable of doing everything, right? So we'll put them in a Twitch poll once we have some folks here. But broadly, here are my thoughts. We can either go kind of cybersecurity focused, do some Try Hack Me rooms, whether they're offensive or defensive. I know Try Hack Me has been putting a lot of work into their new defensive stuff, and it would be, I think, maybe good to have some perspective on that, since yours truly is, I think, still like the only blue team streamer when I get to. So there's that. We can, of course, do some web app hacking. I'm always up to do that. And then on the other side, we have programming stuff. And I thought maybe it would be a good idea to maybe explore sharpening our programming skills with some exorcism challenges, either in Rust, because you know I love Rust, or maybe something a little bit more exotic like Haskell. I know that I need to brush up on my Haskell, and some of you have probably looked at it in fear, but you don't have to fear Haskell. And in fact, there have been some cool changes in Haskell recently, so I thought maybe that would be an option. So that's what's before us today. I will put the poll up. Let me set this thing up. Okay. What's a functional program? It's one that works, Arbrins. And we'll set that up for 3 minutes. So, while votes are coming in, let's talk a little bit about some other stuff that's going on. So, of course, the book, the Home Lab Almanac, is still out. It's available. And it has had some updates thanks to some very diligent readers finding a couple of errors in there, a couple of bugs. But the good news is that because of the way that it's been distributed, the book has been patched, basically, and that folks who purchase the book now have updated versions of it available for download. And you can too, if you head to taggartinstitute.org/p/the Home Lab Almanac, click on the link right there in chat. Or, I'm still waiting on acceptance into other marketplaces, but keep in mind that even if and when I get the book into places like the Kindle store or Nook or bookshop.org or whatever, or Kobo or whatever, it's going to be more expensive in those places, and it won't have all the same features. So I strongly recommend buying directly from TTI, because what you'll get there is the PDF, the EPUB, all DRM free, and you will get a web version of the book that you can use as sort of a searchable reference with a built-in search. So I think that's probably the best option if you're interested in that. But that's not all. We've also been hard at work at something else, which is membership. So this is kind of a new thing, but we have had some pretty good success with it already. Because of the shifting nature of TTI and what we want to keep doing with it, which is providing quality instruction at different levels, but that does require a little bit of funding to make it work, to set up cloud resources, and also to compensate instructors other than myself. So when we invite them to teach, that there's an honorarium that we can entice them with, basically, to say you will get paid for offering this material. I want to make sure that that happens, and the TTI membership is the way that we're doing it. So here's the way that it works for those of you who are unfamiliar. Basically, we are going to use the Discord, which has a built-in subscription system now. There are 3 levels at which you can subscribe. All 3 levels have the same offerings. There is no difference in access for the 3 levels. It's just a matter of your willingness to contribute. That's all it is, right? You don't get like extra perks at the higher levels. It's, what is it? It's $2.99 a month, $4.99 a month, and $9.99 a month are the 3 levels. And again, that's up to you. Any level is going to get you the same access. Access to what, you say? Access to live classes that are a little bit more advanced than what we do on Twitch or even on the recorded YouTube videos, because we're thinking these are, aspiring professionals, but also we have a focused group that can and should put in the work to do some more advanced learning. So that's the plan. We've had our first course. We did Jupyter for incident response. I think it was a pretty good session. I hope the folks who participated agree. But that's just getting started. We have the next one planned out, and the announcement for that will be coming out, I think, this week. And if you are interested in teaching a course and you're part of the TTI community, let me know, because we are looking for other people who have expertise to share and want to share it, and are willing to learn a little bit about how we do teaching at TTI. That, of course, doesn't mean that I'm going to stop streaming. I'm streaming when I can, which right now is kind of rarely, just because of, family stuff that I've got going on. But that still means that there's going to be free content available. I always want to make sure that that's true. And certainly the courses, the TTI courses, are always going to be available for free or pay what you wish. And there are more of those coming soon. I have a lot of plans for the courses on TTI. So none of that is changing. And basically that's been the evolution of TTI, right? It started as the Twitch stream, and now really the focus is on creating the dedicated instructional content. I know it is weird that I'm charging people for courses. I don't like doing it, but there is a reason. I want this thing to be directly funded. I want the instructors to get compensated for their work. For this kind of a thing, they deserve to be compensated, not me. The idea is that for the membership, it guarantees a funding stream for the instructors when they offer a course. So that's the idea. I know it's a little bit strange, but sometimes things in fact do cost money, and I can't change that. They are not introductory courses. Just be aware there are always going to be some prerequisites for what we do in there. You can find out more at that link, membership.taggartinstitute.org. I won't read out this whole thing, but if you're not part of our Discord, you should be. This is where all the good stuff happens. It is, at this point, essentially a full school where we are running courses, we are building a learning community. It is where you should be if you want to learn these skills. I will also just say that, if you are interested in donating to TTI in a non-membership way, I did set up a Libera Pay just so that people have that option. I am not going to push it particularly hard, but I just want you to know that it's there. Okay? So if you're interested in a different kind of supporting the Institute, that is there, but that is not a thing we're going to talk about that much. Any plans on an RE course? Maybe long-term, I think. Maybe once I feel more comfortable with doing reverse engineering. I'm certainly not qualified right now to offer an RE course. And to be honest with you, as long as my buddy Husky has PMAT on TCM, the truth is that course is amazing. And if you can afford it, it's worth it. But I do think there are some opportunities to have something on TTI that is in the same vein. So it's not on the immediate roadmap, but we have some other blue teamy stuff coming up. Paging Sarsek, exactly right. We have our professor of Pwn, Sarsek, who did the amazing oral history of binary exploitation. So the poll ended, I see, and it looks like you monsters are going to make me do exorcism in Haskell. Whoa, okay, it's been a minute, so this is going to be interesting. I guess I can close down Kali then, because I'm not going to be doing anything at Kali. Let me bring up all of the Haskell stuff then. Oh boy. I think I am gonna do VS Code for this for reasons, which will become clear. Do I not have Exorcism set up? I'm gonna have to set up Exorcism on this machine. It's a new build, so I didn't have it set up. That's fine. I always forget where to do that. If you're not familiar with Exorcism, by the way, Exorcism is an amazing platform for learning new programming languages. What they do is you have a set of problems that are common across the languages, right? And with those different challenges, you are taught how to run the code, test the code, and then solve problems in an idiomatic way in the language. But it's better than that, actually, because the way that Exorcism really works is that it's community driven. So there are dedicated mentors that you can ask for help or feedback on your solutions, or you can take a look at the community solutions and see what the community has kind of decided is awesome. Now, one of the differences between Exorcism and a place like LeetCode or Code Wars or whatever is that this is it's much more of a learning oriented culture rather than the like prepping for an interview sort of thing that LeetCode is definitely about. And I will say that the solutions that you see highly rated on Exorcism are much more reasonable than often what you'll see in Code Wars or in LeetCode, meaning the insane one-liners are not actually good solutions from a software development perspective. They may look cool, but they're not readable. Blue Orange's turn asks, what are your favorite Linux commands? Definitely SL. And if you don't have it installed, install it. All right. Let me go install this thing. Installing the CLI. Exorcism could do better about learning. There we go. Okay. So you literally just have to go get the source code. That's annoying. Linux x86-64. All right. And yeah. Okay, sudo cp exorcism user local bin. Cool. RM exorcism. Better. Okay, now I have to use my token. So 1 second to run exorcism configure with my token, which I don't want you to see. I don't actually care. Okay. Let's talk about setting up Haskell, because that's actually kind of a thing. right? Before we can do Haskell challenges, we have to set up Haskell. And the setting up of Haskell has changed pretty recently, I would say. It used to be the case for Haskell that you would go to not Haskell or gethaskell.org or whatever. You would go to a place called Stackage. And Stack is sort of the project management tooling akin to Cargo in Rust or NPM in JavaScript, right? And you would install all of that stuff. But very recently, I guess, Haskell changed this up. Because to use Haskell, there are like multiple different components you have to install. You have to install the GHC, the Glasgow Haskell compiler. You have to install GHCI, which is the REPL. You have to install Stack, which is the package manager, and then Cabal, which is another component. Anyway, to handle all of that, there is now GHC up. So if you go to haskell.org/GHC up, you will get an instruction set very similar to what you get at Rust Up. And so they basically took the Rust Up model and they were like, okay, I guess that's what we're doing. And it's exactly the same. I believe that I have done this. So GHCI, yes, good. I have Haskell installed. I have already done this. With that then done, let me go to, I have Haskell, yeah. I'm going to reset this track, to be honest with you, because it's been so long since I've done these challenges. Yeah. I'm not, I have to do the Hello World? That's fine, we'll do the Hello World, and then we'll move from there. I will do the Hello World exercise. So this is kind of how this works, right? You go through the site, and then there is a command on the side, if you're doing a command line style, and you should, that will tell you what to do. Digital Warhead. Yes. SL is a really fun ASCII animation that will send a little choo-choo train across your terminal if you type it instead of LS. That's the joke. Sorry, I missed some questions. Would you recommend ECTHP if someone is already working as a threat hunter? Yes. I despise INE as their for their courseware, but the eLearn Security certified threat hunting professional cert, which I have, is one of the best certification exams I've ever taken. And the breadth of knowledge that it requires, I think, really adequately prepares you for the reality of threat hunting, because you don't know what you're going to be doing on any given day with threat hunting / incident response, especially if it's a mixed role for you. So yeah, the exam covers things like memory analysis, static analysis, dynamic analysis of, by the way, multiple kinds of samples. You know, whether it's a Linux ELF, whether it is a Windows PE, whether it's a .NET assembly. It also covers looking for threats from a SIEM perspective. So you may be working in Splunk or working in Elastic, whatever. So definitely, I strongly recommend, if you have somebody paying for it or you can afford it, the eLearn Security Certified Threat Hunting Professional exam. I don't know if INE still has, like, I think their courseware maybe got better, but I found it to be mostly useless. I prepared for that exam using every other resource that we use on here, right? TryHackMe, Let's Defend, Cyber Defenders, things like that. Hey, Seth, thanks so much for the follow. Okay, so got Haskell installed. For those of you who aren't familiar with Haskell, and you're like, why is Tagger talking about this weird language, and what's the inside joke? Okay, Haskell is a functional programming language, and what that means is everything in the language is a function. There aren't loops, and there are conditionals, but everything is a function, and those other structures really just serve the returning of values from functions. It is declarative, it's also known as declarative programming as opposed to imperative programming. What's the difference? So imperative programming is what you're used to. You write a series of instructions like a recipe with maybe some conditionals, loops, things like that alter the flow of the code, but it's instructions in order. And at the end of the day, that's what the CPU is going to be doing anyway. But from a reasoning standpoint for humans, there is a material difference between imperative programming languages and I would say functional, not declarative programming languages, but declarative is like Prolog and it's weird. But and functional programming languages where you are not thinking about the data or the problem as a series of steps, but more how to transform information from one shape to the next. And it changes the way that you think about things, and it even changes the way that you can solve problems. And once you have a handle on functional methodology, you can use it in languages that aren't Haskell. So why Haskell? It's very popular in academic computer science to teach this sort of concept. It is by no means the first functional programming language. Chat, what was the first functional programming language? Somebody can go find that on Wikipedia. And be probably surprised how old it is. But what Haskell does have is a really clean syntax. And because of its clean syntax, it really helps people reason in this way. Lisp is correct. Yes. 1955. That's right. That's how, at the beginning, right? It was, I think, Fortran and Lisp. And there were basically two schools of thought about how people should program computers. You can maybe think about Lisp and the functional track as sort of the Betamax of this. Like, there were things that made it better, but also things that made it worse. But it was kind of counterintuitive because the functional part, while mathematically beautiful, was so abstracted from the way that the machine worked, which was instructions in order, that it didn't make any sense to write code that way for the machine that wasn't interpreting code in that way. So just think about that. Okay, sorry. History lesson over. Let's get Hello World going. So you can use the built-in. Exercism has an editor. I don't like using it. I like using my own tooling. So I am going to run this command. It should download this. By the way, let me know if the text on the terminal is too small. I will zoom it in. Okay. And we'll go to Haskell. Actually, okay. Next question. No, I'm not going to leave this one up. I'm going to use VS Code first. I hope. The reason being that the Haskell integration is really good and the NeoVim Haskell integration is not. I hate to say it, but that is the truth. So let me just make sure I've got the Haskell extension. Oh wait, is this? Yeah, there we go. And it looked like I had a couple reload required. I don't need PowerShell. Did you install the Haskell language server for use in VS Code? GHCup does that for me. So yes, yet another reason why GHCup is cool. It is like a reasonable stand-up for development in Haskell, which has been sorely missing. See, look, VS Code is asking me, how do you want the extension to manage, discover HLS in the relevant toolchain? Automatically via GHCup. Yes, absolutely. And it figured itself out. Looks like we're good. Right? That is good. That is a good development story. Okay. For those of you who are unfamiliar with Haskell, we're in the right place because we're going to go through what the Haskell syntax is and how to read this, and then we'll do some reasoning about it. So we're declaring our module hello world, and in the parens, these are the functions that we're exporting. There is a single function. This next part is usually where people start looking a little askance at Haskell syntax, because every function definition, it takes at least 2 lines. There's a function definition that's about types and return. And then there is the actual implementations. So line 3 here says hello is a function that returns a string. In this case, it doesn't take any arguments, so we don't see any other arrows or anything, which we will eventually. And then we declare that this, which in every other language would be a variable, right? But in Haskell is a function. The function hello returns the string goodbye Mars right now. That is what we're saying. Now we could write another function called greet. And it would look something like this. If we wanted to say that it takes a string like a name and returns another string, right? And if we say greet name equals hello, and now I'm going to have to remember how to do string concatenation in Haskell, which I think isn't plus, right? Or is it? This is why the GHCI is so useful. So exorcism Haskell hello world. cd hello world. This is how I develop in Haskell when I have to. Hello plus u. No, it is double plus. I was right about that. Okay. So this is the interactive version of Haskell where I can run one-liners. And I can also load files. So hello plus plus name, and we'll toss an exclamation point on the end of it there. Okay, we'll load this up, and then with L source hello world.hs. Okay, so now that we've loaded that, we can run greet. I forgot quotes. There we go. See how that works? So I can also add multiple arguments that the function would use. So if it takes 2 string arguments, it would look like this. And then I would just be declaring my punctuation. Like that. I have to, by the way, reload the file every time I do that. So now if I do greet with a question mark, right? Now it's using the punctuation that I put in. Just to demonstrate multiple arguments for a function. One question I often get is, or one question I don't get, everybody gets, is why is there no distinction here between the return, which is the final string here, and the arguments in this function signature? Why do they all look the same? There's like a cool mathy reason for it. And I bet R. Brins knows what it is, but does anybody else know what it is? This is, by the way, the most mathy I'll ever get. We're running the tests for the thing right now, which will fail. That's okay. Nobody, huh? The answer is known as currying. Yeah, that's the language name thinking. Haskell Curry is the mathematician who discovered or wrote this theorem. And it basically says this. I'm going to try to get this right, and Arbrins can keep me honest. A function that takes two arguments is the same as a function that takes one argument and returns a function that takes the next. Let's say that again. A function that takes two arguments is the same as a function that takes one argument and returns another function in which the second argument is provided in the final return type. What that means is that from Haskell's point of view, what's actually happening under the hood here is we can do what's called partial function application. We'll get into that, but basically we have a greet function that takes a string and returns another function that takes a string that finally returns a string. That is the same thing as saying we have a function that takes two arguments that are strings and returns a final string. That is why there is no distinction in Haskell between the arguments, the precursor arguments, and the final return type in the notation. Because per function currying, which is what that refers to, there is no difference. Yeah, it's all like, it doesn't take long working in Haskell if you've never done functional programming stuff before for your brain to grow, because there's so much cool stuff that is embedded in this language and the way that it makes you reason. For sure, like my time going deep on Haskell, which is a while ago now, made me a better programmer, and I've taken those same methodologies into things like Rust. Which can be very functional if you write it that way. It's designed, I mean, it has OCaml DNA in it, so it has that capability of being a functional language. In fact, I would argue it wants to be a functional language. Okay, so our test failed, of course, because we didn't actually change the string to hello world. Right? Now we can knock off this extra thing. That was just for demo. We're going to run stack tests. So stack, as I said, is the sort of package manager. There are also built-in tests from this exorcism thing, right? And it's saying that we're looking for hello world here. And so we're going to run stack test. Boom. Okay. Test passed. Looks like we're good. We can then submit this solution with exorcism submit, and the hello, just send it the source code file. And then we can take a look at it in the web browser on the site, and it should say like, hey, good job, it's processing our result. Now, one thing I have found with Haskell specifically, maybe it's like a whole thing with exorcism, is that sometimes I'll get fails because the tests time out, and that's a resource problem, but your code is still good. You just run the tests again and it's fine. Looks like we passed, so we'll mark this as complete. This is fine. I don't need to share this. We just mark the exercise as complete. This is hello world. We don't need to share it. But we're definitely going to see more exercises. Okay. What's a fun one? Space Age is actually a good one. Shout out to the Nebula class starship in the back there. Learning Haskell makes me a better computer scientist all around. I will never claim to be any kind of a computer scientist, but I do think that it makes me think about how I structure my code better. All right, so here are the instructions, and we'll pull this down in the editor. By the way, if you like what you're seeing here, my shell setup situation, I have this all available in a GitHub repo. Yeah. If you basically want to copy my shell setup. This will set up Fish, Terminator, Alacrity, Tmux, Vim, and NeoVim for you. The way that I do it. And then you can take it from there. The custom shell is done with Starship. And I've just sort of customized the colors and everything with a palette of my choosing that made sense for TTI. All right, let's close out of GHCI. Let's go up to Space Age. Cool. Okay, so let's think about what the problem is here. And we'll open it up in VS Code. Ah, this is cool. So we've actually gotten a bit of a start here based on the way that it's defined this type. Okay. Given an age in seconds, calculate how old someone would be on Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. No Pluto? So if you were told someone were a billion seconds old, you should be able to say that they're 31.69 Earth years. Okay. Oh, if you're wondering why Pluto didn't make it this cut, go watch this YouTube video. What is this YouTube video?
Pluto.
This is an old video, and Pluto's back in, baby. Also, Neil deGrasse Tyson can bite me. Not just because of the Pluto thing. Because he's a poor substitute for Carl Sagan. Okay, so let's think about the way that this is structured. A lot of Haskell, like, a lot of it isn't writing a lot of verbose code. A lot of Haskell programming is really just reasoning, thinking about what we need to do. Okay, so we have this data. And what is this? We're defining a type. This is a data type. In this case, you could also think of it as an algebraic type or a union type, where we have a single type planet that has these different variants. You could call this an enum as well, if you're familiar with that terminology. Right, these aren't strings, these are separate variants of a single type. And the reason we're doing that is because we're given a planet, and we'll create a conditional for that, right? We have a couple of ways to do conditionals, by the way, in Haskell, so we might explore different ways. But and then we're given a float. Say you need to implement this function. So, and the second. So notice the second line of the function definition kind of matches here, right? So this is the planet, this is the seconds, which is of type float. Okay, and then we need to return a float. So to make the function work as intended, we could just give it like 5.4 or something like that, which will pass a simple compiler check for type, but that's not really what we want. Because we have these different variants of the planet, one way we could write this is with a case planet of. And then we can kind of work this. And I think we usually do that kind of indentation like this. I used to like Neil deGrasse Tyson, but he turned it to. So I did too, kind of. I like Neil deGrasse Tyson because I like the idea of having somebody else picking up Sagan's mantle. But he's just bad at it. He's bad at it because he's too interested in being right and too clever by half. And also, did we ever find out what happened with all those accusations during the Me Too movement against him? Like, I don't think we ever landed on a definitely no for those. Did we? I'm not sure. So Chris Pine wrote an online learn to program? That's cool. Probably not the Chris Pine I'm thinking of. So case planet of. So the way this works, right, if we do Mercury, and what is it? Like, no. It's double arrow, right? Yeah. It's plainly not double arrow. Is it just equals? Is it single arrow? It is single arrow. Crazy. Okay. So Mercury, what is the Mercury calculation? It's okay. So it's 0.2408467 Earth years, but we're not given years, we're given seconds, right? So we're told how many seconds old. So the first thing to do is figure out, like, what is the calculation to get from seconds to Earth years, and then multiply that by this number. So seconds to Earth years, right? So that's going to be seconds divided by yeah 60 divided by 60 divided by minute, hour, day, year. That seems right. Now, here's the problem. We're going to have to do this part for every single one of these. So putting it here is silly. And by the way, if my math is way off, please check me on it. Actually, nope. Up here. Let Earth years equals in. Boom. So again, because it all has to kind of flow down and the function has to return, we define this variable with a let clause, just like in Nix, the way to be used in our cases. So in this case, it would be Earth years times and then whatever the Mercury constant is. Okay. Hey, just a guy. Good to see you. And otherwise, we'll just return seconds like this. Okay. So we're not getting any syntax errors, at least. So let's run the test and see how we do. I want to see if the Mercury case passes at all. Oh, they wanted Earth. Luckily, we can just give it Earth years. Ooh, that's interesting. Oh, wait. I think I know why. Look how close that is. Yeah, that's why. Note, the actual length of one... I didn't finish reading. The actual length of one complete orbit of the Earth around the Sun is closer to 365.256 days, also known as one sidereal year. That's how you pronounce that, by the way. So while not entirely accurate, 365.25 is the value used in this exercise. Very good. So we will modify our code to use 365.25 as opposed to 365, and that should sort out Earth. Okay, Earth passed, Mercury failed, though, in a pretty goofy way. Like, way off. Right? Why? Because I multiplied and I probably should have divided, right? Yeah. There it is. My math was wrong, but in a very fixable way. So, we've got the logic down. Now it's just a matter of completing the rest of the code. Right? Earth. Is it... Okay, I just have to ask if it's just me or not. If these aren't in orbit order, it would drive me batty. So we obviously have to do Mercury, then Venus. Earth years divided by... what's our... Yeah, use that. Okay, Earth, Mars, and yes, you do want to be a little bit anal about your formatting with Haskell. Jupiter. I just finished watching the Expanse not that long ago, so I want to like put series and everything in here. Beltalowda. By the way, if you haven't read the Expanse books, absolutely do so. They're fantastic. Also, apparently came out of the authors playing a tabletop game. We don't need this because what you're seeing here, Haskell's like, hey, you don't need the null or like the catch-all because you have accounted for every possibility of the planet type. So I want to pause on that for a second. That's kind of a cool thing, right? If you define an enum, the compiler will be smart enough to know when you've accounted for all the types. That's very similar to how that works in Rust. Okay, this looks pretty good, and it's about as clean as it gets. There is another way to do a conditional like this in Haskell, and we'll talk about how to do that. And honestly, it's just a matter of syntax at that point. But let's see how this goes. Boom! We did a Haskell. I want you to look at this syntax for a second, especially if you're unfamiliar with Haskell, and think about, how this differs from how you would write it in an imperative language like Python or C or JavaScript or whatever. Honestly, in this case, not that different, I would say. And especially in Rust, this is just a match statement, right? Almost identical, which is why I say that Rust kind of wants to be functional. The other way to write this, if you wanted to do it, is you could have done something like, comment this out, something like age on, planet, seconds, and then planet equals Mercury equals and then written the function that way. So what you have is a guard. These are called guard clauses for each of these. Okay. So planet equals Venus. Now, in this case, this is the wrong way to do it because all of these are just comparisons for the type, right, of the planet, and the case makes a lot of sense for that. But when you have varying kinds of conditions that you need to test for, this kind of guard clause is really cool because at the end of it, you can also do an otherwise and just give it whatever the base case is. So kind of two ways of doing conditional based returns in Haskell. When we're dealing with data types like this, I will almost always default to using the case of because of its cleanliness here. The fewer, I think about it this way, the fewer equal signs I have to write, the better. Seems like a goofy rule, but it serves me well in Haskell. All right, this looks good. Exorcism, submit, source, space age.hs. By the way, we're doing this, but I've been gone for a while, so please feel free to ask any questions. You know, if you have questions about career stuff, other things that we do with TTI, we can always consider these AMAs, especially now that we're kind of loosening up the format. Also, I hope everybody's doing well. I should have said that at the outset. It's nice to be back with all of you. Okay. See? So look, I got a failed, but we just saw it pass the test. So what happened, right? The fail will show me. Oh wait. Could not load module diff time. Did I import that? I didn't even use it. That's so funny. I didn't even use that. Was I supposed to? All right, tests are running. This one passed. Even though it says passed here, even though the test didn't. Okay, all tests pass. Hooray! Nice. And now we can look at community solutions and see how other folks did it. And right now, by default, it's sort of sorted by stars. So this is pretty similar. Identical to what we just did. Now, oh, I should have mentioned, this is another way you can define differing implementations of a function in Haskell. What you're looking at here is the same function defined without a variable for the first argument, just like this is the version of the function when the planet is Earth. So it's literally multiple different, what's the term? Variadic function definitions. Is that right? Or is it polymorphic in this case? It's not variadic. It is polymorphic. So basically, you're creating a polymorphic function definition by rewriting it for each of the possibilities for the planet type. Oh, just a guy. 2 questions. I saw some stuff regarding Linux from TTI, and it would be great if you could let us know what your plans are for TTI's immediate future, and last but not least, how's life on your side of the world? Okay. Start regarding Linux from TTI. What are the plans for TTI's immediate future? The plans for the immediate future are to stream when I can, and to continue focusing on course material, and live classes with the membership. So we have a couple of live classes lined up. So that's kind of like one big focus. And then in terms of course material, I have kind of 2 or 3 courses that are in the pipeline, not just from me as well. I have a couple of other people who are working on pretty exciting courses that'll be coming up soon. Maybe one of them or 2 of them will be released before the new year. There's some like meta stuff, not with the company, but sort of meta stuff that I want to do about helping learners be what's known as SDL, or self-directed learners. So part of that is, I think one course I want to do is on how to be an effective self-directed learner. So learning how to learn, because a lot of times you're tossed into this situation, you have to learn these skills to get a job or to change a career, whatever it is, and you've never been taught how to do that. For most people, the formal learning that they do in school is so structured that when they are not given that structure, it's difficult for them to put it together on their own. And that's not a personal failing. No one gave them the tools. That's okay. So when I think about this a lot, because the truth is that platforms like TryHackMe or Hack the Box Academy, they provide a lot of great information. But what they do not do is structure a learning path for a self-directed learner, thinking about what the needs of that learner are to make use of that information, how to process it, and super importantly, how to assess themselves in a way that is more meaningful than filling out a flag that you caught during an exercise, because that doesn't actually mean you understood anything. It means you got to the flag, but it doesn't mean that it's reproducible, and it doesn't mean you can explain exactly how it worked. Those are the things that are really important, and also that are technically difficult for a learning platform to test, so they don't. That's kind of what the gap I want to cover with this course, and using tools like Obsidian or other planning utilities to help make sense of your knowledge. One last thing I'll mention for the sort of medium to long-term plan is instructor certification. One of the things that I feel like I am bringing to the conversation in InfoSec that is missing is ed theory, is a background as a formal educator, and specifically in education leadership, learning how to build a curriculum, learning how to teach teachers how to teach better. And so what I want to do is, in conjunction with offering more live courses and maybe in person, I wanted to do an in-person training and then it fell through. Train other instructors in the things that I and some other folks at TTI figured out work for this kind of learning. That is kind of a big long-term goal, but I want there to be such a thing as a Taggart Institute certified instructor. And that means that you understand the needs of remote learners, you understand the needs of self-directed learners, and you can deliver knowledge and facilitate the development of knowledge and understanding in learners in those ways, following the principles that we've kind of laid out. So that's kind of like the overall broad roadmap. Hopefully that answered that question. As far as life on my side of the world, it's crazy. It's a lot of fun. My daughter is, a few months old now, and she's a lot of fun. She's a lot of work. And so learning how to balance things and being honest with myself about what I have time for and what I don't, that's kind of a learning project of my own right now. I love being a dad. I've always wanted to be, and I'm excited to do it well. So that's still my first priority, of course. And so trying to figure out where I can fit other things in is I'm still figuring out how to do that well. Okay, next challenge. I want to do one where we actually have to do some cool stuff. Oh, Hamming is fast, but it's a good one. Calculate the Hamming distance between two DNA strands. This is a good one for Haskell-y reasons. Let's do this. Brins, are you satisfied with our Haskelling today? Hopefully it's not too low level for you. It may well be. One thing we haven't really gotten into is how you learn what stuff there is in Haskell, because we haven't really explored all of the varying functions there are and modules there are in Haskell. We've been pretty lightweight in that so far. There are tons, and the place that you can find them all is Google. Not Google, Google. Google is really neat. It's kind of set your different package types, but learning where, like, what different functions do and how they're defined. So for example, words is one, which is kind of cool. Look at that. So we just learned that there's a bunch of different functions called words in different libraries. This is the primary one though, this words here. What does it do? Word breaks up a string into a list of words, which were delimited by white space as defined by blah, 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 blah. And here's an example, right? So it will create a list of words. So that's just a thing that exists in Haskell. And there's a bunch of those, just functions that exist in Haskell. There's even unwords. Notice that. This, like, joins words with separated spaces. So this will take a list of strings and space them. These sorts of things are available, and you have to kind of learn, just like Rust or other documentation, you have to learn how to read the documentation, and that can take some time. So for example, zip is a good case study for what the... Go back to zip. What this is saying is, brackets, zip takes two arguments, a list of type A, whatever that is, a list of type B, they don't have to be the same type, is what they're saying, and returns a single list of tuples joined A and B. One interesting thing I should note is that the function signature here doesn't tell the whole story with zip. If one input list is shorter than the other, excess elements of the longer list are discarded, even if one of the lists is infinite. And yes, you can have infinite lists, sort of, in Haskell. It's something called lazy evaluation. You can define very large iterations that, until they need to be computed, won't be, and so they don't take up the space that you think they do. All right, what are we doing here? We're calculating the Hamming distance between two DNA strands. The Hamming distance is, if you line up two strands of DNA, what are the differences? How many differences are there? That's the Hamming distance. This is a cool one because I think we can do it with a fold. And folds are important in Haskell. So if we think logically, we take two strings for each one, like we go through an index or something like that, we compare index 0 to index 0, index 0 in string 1 to index 0 in string 2. If they match our accumulator, where we're adding our distance is incremented. Or sorry, if they're the same, we keep it the same. If they are different, though, we increment that accumulator. That's kind of it. So let's go and reason about that in Haskell. Okay. Ooh. They threw us a curveball. Look at the return type. They're making us return a monad. Oh no. Maybe int. Why would it be a maybe? Maybe is interesting. If you're used to Rust, think of a maybe as like an option. Meaning a maybe is a way of returning data when you're not 100% sure there's data to return. It's really the best way of putting it. Yeah, there we go. The maybe type encapsulates an optional value. A value of type maybe either contains a value of type A, represented as just A, or it is simply represented as nothing. So I'm curious why. Let's look at the tests for this to see, is there a case in which it's expecting a nothing? Ooh, disallow first strand longer. Yes. Second strand longer. So basically, if there are empties, or if there are... Oh, we could also do this recursively. Actually, I think let's do this one recursively. This is going to be fun recursively. But yeah. Okay, so return nothing. Okay, I think I can see this function. So the strands have to be the same size, and they can't be empty. Great. We're going to get into some fun things we can do with function definitions. So this is x's, y's. We can do distance x's, y's equals nothing. Distance, see, so I can, just like we saw with the planets, if I explicitly say it's an empty list, and a string is a list of type car, let's make sure that's true, right? So it calls it a string, but these work the same way. Strings are just shorthands for list of cars. Very similar to C, actually, in that regard. So distance x's, y's equals nothing. Okay. So already we've kind of handled two different cases of empty, right? Yeah, length will give us the length of a string. We haven't really invoked functions in line yet, so what does that look like? If we give length a string, it'll give us back that integer. So this is a situation in which it might be useful to determine whether our x's and y's are the same size. Well, let's see. Does it matter? It does matter. Not equals is very confusingly slash equals. It's not bang equals in Haskell. So, okay, we're handling the varying lengths. We're handling the empties. Is this the way I want to write this? Like I said, a lot of Haskell is just like thinking, because the code is pretty succinct. What I'm trying to do is think about an elegant way of making this recursive. Oh, never mind. To make it recursive, we would have to change the function signature, which we could do, but we'll do it later. So in this case, we actually do get to do something cool with this. So we are going to use a fold. What is a fold? A fold is a function that has a very specific type signature, and we've actually already seen foldable already. Fold, we'll do fold L. Look at that function signature and just weep, because it's not at all clear what this is doing, right? This doesn't make any sense. But you know you've used folds, even if you don't know that you've used folds. A fold is a function that takes three things, basically. It takes a function of a special shape, hold on to that, a sequence of things to iterate through, and a starting point called an accumulator. And what it does is, for every member of that sequence that you're iterating through, it runs that function, which was the first argument you gave it. Now, that function itself has two arguments. In this case, the first argument is the specific element of that sequence that you're working on at the moment. And the second argument is that accumulator. At the end of the day, the fold function will return the value in that accumulator. Now, that value could be a created list. It could be a single scalar value, like an integer, like a sum or something like that. It could be a concatenated string. What that means is you've actually seen folds, whether you knew it or not. You can define the sum function as a fold. In fact, it is a fold, right? We'll demonstrate that a little bit more cleanly in just a second. So let's say we'll call yeah, if we are given a list of integers, it returns an integer. Can I just do fold sum? Yeah, fold sum equals, and fold sum int, or fold sum i's for integers equals fold L plus i's fold sum 4, 3, 2, 1. Dang it. Type signatures and rebel. Yeah, the problem. Let's not define it. Let's just run fold L. So the other way we can do this is with anonymous functions. So if we take i's, right? We'll say i's equals 4, 3, 2, 1, and we say fold L for fold left, meaning we go left across the list. So the first is the I, and then the next is the accumulator. Say A plus I. This is how we do anonymous functions in Haskell, also known as lambda functions. Eyes on. No instance for show integer. Oh, i's 0. I just had the order wrong. Fold sum is fine. The accumulator comes first. Yeah. Okay, I'm gonna leave that alone for the moment. That's an unparsable error. This is like my least favorite thing about Haskell, is that the errors are unreadable. But fold L, the part I wanted to elaborate on here, is... Oh, plus is wrong. Hold on a second. Not plus. There it is. Fixed it. I was using list concatenator rather than addition. So fold sum here, these two things are saying the same thing. We are adding I to the accumulator on every round of the function run. So that's how sum can be done functionally, right? And we can see it here. We're folding L, and what we're doing is we're applying plus literally to just everything in I starting from 0. That's it. That's it. If you think about it that way, a whole bunch of stuff becomes a fold. In fact, even map is a fold. All right, if you're used to mapping a function against things, it's just a fold under the hood. So what does that mean? Well, think about what we have here. We have two strings. And we need to run a fold against a single list. And we had this rule that they had to be the same length. What if we could make both lists into one list and compare the two elements side by side? What if we could do that? We can! We just saw how with zip, right? If we take zip and give it look, we now have a single list over which we can iterate. So our sequences are this, and then we can do something like map And let's just make an anonymous function for a second. So call this x, because I don't have a better name for it. This is how we index x1 seeks. Couldn't match type car. Oh, sorry, that was dumb. A, B. I can destructure the tuple. I totally forgot that. A equals B. There we go. I was doing more work than I needed to. I was thinking imperatively. So I can destructure the tuple, right, and get access to the two elements, and then do the comparison against it. What that means then is here I can run a yeah, I want to do a fold L, and the anonymous function will be like this. It'll be like A, B. And then if A equals B, then A plus 1, else A. Oh, so A, B. Let's actually call it X and Y, right? And then the accumulator is A. So if X equals Y, then A plus 1, else A. So that's the function for fold. And we know that fold now takes a starting point, which is 0, of course. And then what is our starting list? So the starting list, we could define earlier, or we can define it inline. Let's define it inline because we haven't done that before. We wanted to do zip x's and y's. But now we have a problem, because zip x's and y's, this shouldn't be guarded. There we go. X, Y. Oh, just should be better. So we're getting this like really weird error here. And the reason is that fold, at the end of it, it says, oh, we've given it too many arguments. And we have, but it's subtle how. So we're doing this fold, and here's our fold takes, as I said, function, the starting point for the accumulator, and the sequence to iterate over. Okay, so fold, then we've got the function, this thing in parentheses, so that's 1. 2, our starting point is 0, and then 3 is zip x's, y's. Aha! Because we don't have any sort of delimiter between these, Haskell's like, you gave me way too many arguments. Why did you give me 6 arguments instead of 3? Right? It thinks. And so that's no good. We have a way, we can of course wrap this in parens. And that should help. I don't know why it's not. Maybe int. It should be good. Okay. Oh, there we go. So this is actually the problem, is if we wrap this in parens, list of integers. Accumulator comes first, then it's weird. It's like the ordering of them is backwards from what we just did. But whatever. So we've got our accumulator. Then we've got our destructured tuple for xy's. Good, good, good. Now, this is a lot of parentheses. Is there a way to clean this up? There is. In Haskell, we can use the $ operator instead of some parentheses. So instead of these outside parentheses, and instead of the parentheses around zip, because we can use the $ here to offset. What this $ says is the next thing is in parens, basically. Consider the next expression as a whole argument. This looks pretty good. Let's go ahead and run it. Ooh, distance empty strands. Expected just, oh. I forgot a case. And we don't have to define the y's in this case. Our quick fix here. Pattern match is redundant. What is failing? Distance empty strands. Oh, expected just 0, not nothing. Interesting. Okay. So nothing was only for when they're not equal? Okay. Welcome to test-driven development. Single letter identical strands. Oh, there's another case, which is where they are single length. Now, this is getting very funky in its conditionals, and I don't actually like that. See how we've gone further here? Okay, so single letter different strands. Expected just 1. Oh. Yeah, see? Now we're starting to find all these weird edge cases. So this is like a style thing or like an instinct thing. When you start finding all these funky edge cases when you're writing something in Haskell, sometimes there are just hard problems, but often it means that the overall structure of what you're working on is off. And there's another way to do it that's going to be cleaner. And I really think that's what we're looking at here. The way that this could be cleaner is, what if we had a function that all it did was compare two genes, codons, one like A to T or whatever, C to G, and yeah, they're codons, right? I'm trying to remember high school biology, but a single like adenosine, cytosine, guanine, those are called codons, and then like a sequence of them is a gene. But just analyzes 2 of them and returns 0 or 1 or whatever, right? And then what if we were able to run that recursively for like one piece at a time along a string, so that the right sum would show up at any given point. So the way that you usually do that, if you have to have a function that plays with something else that has a certain signature, is you would write another function called distance prime. And what this does is it takes a string and another string, and it takes an int, which is our accumulator. So we're going to kind of do a fold, but not quite like this. And returns an int. So distance prime so we don't do empty anything. Empty strands it doesn't do. Single letter identification, single letter different. So we have to do empty strands we've kind of already handled. Although I would like to do, if this is going to be recursive, we have to think about what the base case is. So the base case what we're doing here, this is a cool Haskell trick, is we get to chop the list and say we're going to take the first element of our X string and the first element of our Y string and consider it separately from the rest. And again, we're gonna, actually our base case is empty. So our base case is empty. Then if we have we'll do case X equals Y of actually no, this one we can do a guard for. A guard would actually make more sense here. So X equals Y equals distance prime x's y's, which now has the first part of it chopped off, and then we give it in the accumulator, which by the way should have ACK here, ACK plus 1, which we will $sign. So what we're doing is we're evaluating one element, and oh, it's actually just accumulator, and then otherwise equals distance prime x's y's ACK plus 1. So yeah. And actually I don't even need the $sign there. So if they match, we don't increment the accumulator. If they don't match, then we do. And what this does, because we're destructuring, we're taking the X and Y and considering them separately for each one, we are able to keep sending smaller pieces of the list through the same function. Until there's nothing left. There's an empty string left in the X's or Y's. X's and Y's, because we're guaranteeing that they're going to be the same thing. So this cleans up this entire situation, right? And we get rid of this equal sign. Oh, now what's our problem? There we go. Okay. Just $sign. There we go. Okay, this looks pretty clean. Doesn't this look cleaner than what we had before? Now, I may have made a mistake in the way that it works, but this is a very common pattern in Haskell where we will write, and this is a recursive function. Notice that it's calling itself, but it's calling itself with smaller and smaller chunks. Okay. Incomplete patterns. I'm not worried about that. Well, let's see. So single letter, different strands. Oh man, I didn't even realize that I had that enabled. Okay. I think I'm set up for that. Oriobyte or Dean play me a song. Wow, been a minute. Yes. Wow. Okay, yeah, it's been a hot second. Oh, it's not a bad time. I just, You know what I have to do? I have to reinstall the DroidCam client. It's been so long. So let me set this up. But let's also think about single letter different strands. Expected just one, but got just 0. Single letter different strands. That should have... Oh, you know what? I see what the problem is. There it is. Okay, we got farther. This allow first strand longer. We may have to do a separate conditional for that. There we go. Yeah. That's sort of like how it was. Okay. And then piano up. This.
Testing. That sound okay? Thrill as I struggle with the headphones. Hopefully this is sounding okay. Somebody in chat, let me know. Winds on forever, I'm gonna see where it leads. Oh, there's a mountain that no man has mounted, I'm gonna stand on the peak. Out there's a land that calls for me, girl, I wanna be the first to arrive. No time for pondering why I'm wandering on while we're both still alive. To the ends of the earth, would you follow me? There's a world that was meant for our eyes to see. To the ends of the earth, would you follow me? If you don't, I'ma say my goodbyes to thee. Silent, I'm gonna whistle a tune. Oh, there's a desert that size can't be measured, I'm gonna count all the dunes. Out there's a world that calls for me, girl, headed out into the unknown. Wayfaring strangers and all kinds of dangers, please don't say I'm going alone. To the ends of the earth, would you follow me? World that was meant for our eyes to see. To the ends of the earth, would you follow me? If you won't, I'ma say my goodbyes to thee. I was ready to die for you, baby, doesn't mean I'm ready to stay. What good is living a life you've been given if all you do is stand in one place? I'm on a river that winds on forever. Follow till I get where I'm going. Maybe I'm heading to die, but I'm still gonna try. Guess I'm going alone. To the ends of the earth, would you follow me? If you won't, I'ma say my goodbyes to thee. To the ends of the earth, would you follow me? If you won't, I'ma say my goodbyes to thee.
Ah, wow. Been a minute. Okay, let's go fix this thing. And then I gotta get going. Different disallow first strand longer. Okay, so we have distance here. You know what? Easy days. We'll just do a guard here where we'll do length x is not equal length y's equals, should that be just 0? Hey, Full Stack Live, thanks so much. This would be otherwise equals. Okay. What is it? Let's read the test. It should be nothing. Interesting. So it actually wants a nothing for first strand longer. So in this case, it's not just 0. It's going to be nothing. Okay. I play all sizes of keyboards from church organ. I do not play the church organ. The 88 keys is more than enough for me. Disallow left empty strand. Okay, so this should have been a nothing. I guess in both cases this should have been a nothing. Oh, come on. Empty strands. Expected just 0, but got nothing. Now it says it's redundant, but oh no, that's not gonna work. Right. If I put it first, oh, see how it fails down? Success. Now we're getting told defined but not used wise. Oh, I think that I can basically say ignore this variable just to get, I'm trying to get rid of that compiler error. Okay. And then it says pattern matches are non-exhaustive in an equation for distance prime. That is true, but it also kind of doesn't matter because we've accounted for other possibilities before it gets there, right? So I think we're good there. Exorcism, submit. This is almost certainly not the cleanest way to do this, but I do like the fact that we used a recursive algorithm. I like the fact that, again, so what distance prime does is that it takes each gene sequence, right, examines the first element, and then passes the rest onto itself until there's nothing left. And that is a very Haskell-y way of solving problems. And you can take that same instinct and use it in other languages. But I will say something specifically about Haskell, because sometimes when you're doing recursion, people who think about like computer science stuff or low-level programming stuff are like, wait a minute, how big is the stack going to get? That is something to think about. But in Haskell, actually, when you write a recursive algorithm like this, under the hood, sometimes the compiler is smart enough to turn this into a loop in assembly, not a recursion. So it's not like you're ending up in a like multiple stack frames deep in the recursion. In this case, you might because it's tiny. But when it's heavy, it's actually smart enough to turn it into a loop at the end of the day. So there's all sorts of interesting compiler optimizations in Haskell that allow you to reason in functions, but still write sequential instructions, because at the end of the day, it's going to be assembly for the CPU anyway. That doesn't change. All right. Where's Hamming? Oh, hey, it passed. Awesome. Cool. I'll mark this as complete. Yeah, sure, I'll share this. Doesn't matter, but I want to see other solutions for this, though, and then we'll get out of here. Other ways to do it. So this is a beautiful way of doing it. Look how short this is, right? So we knew that the length was a problem. Otherwise, check this out. Using built-in zip width, of course. Built-in functions. So just length, filter, ID, zip width not equals x's y's. So it's using a bunch of built-in functions, filter, ID, and then zip width and a function applied to x's and y's. So you're getting like true, false, ID, and then filter for ID. And then that gives you basically the length of how many matches there are. This is a cool Haskell way to do it, but is it clear to you what it's doing? That's something to think about, is like, this is so clever, but I don't necessarily know that it's clear what it's doing without deep Haskell knowledge, which is like, okay. All right. Well, friends, this was a lot of fun. I had a blast. I hope you did too, and I hope you learned something. I got to get out of here, but I'll be back at some point. I don't know when, but whenever I can. But in the meantime, there's a lot going on at TTI. If you haven't joined our Discord, please do. Also consider becoming a member, because then you'll have access to the live classes that we're doing, and that's really where some really advanced stuff is happening. I'd love to see you there. I'd love to teach you in a live situation where you get direct interaction with me and other instructors. So until next time, friends, please be good to yourselves, be good to each other, and happy hacking. And of course, we're going to try to find somebody on InfoSec streams to raid. Nobody I know is currently on, so we'll just let you have the rest of your weekend. Take care, friends. Oh, Tannis. Okay. If GoPro swears by them, then I will go to them. All right, we'll raid them, and I will see you next time.